So we've recently added Regtest in Zebra, and Regtest in Zcashd and Bitcoind is a mode where a node is going to work on an isolated network for the purpose of running integration tests with wallets, for example, or exchanges or other use cases. And it makes it very easy to add blocks onto the chain. In Zcashd, it uses different Equihash parameters that are much easier and a lower target difficulty. In Zebra, currently, it disables proof of work altogether so that you don't need to have a valid block hash or a valid Equihash solution at all. And this is how we can test consensus rule changes as well, or any other kind of custom functionality in a private, isolated environment. It allows for configuring custom network upgrade activation heights, and it's a special case in Zebra of a custom testnet, which is a public testnet with custom parameters. It also allows you to set custom network upgrade activation heights, as well as a number of other parameters. This is all available in the Zebra book under 1.14 custom testnets and 1.14.1 Regtest with Zebra. So let's start with Regtest for today. And it makes it really easy in the book to just copy paste this config into Zebra. And today we're going to show you how to use this with the internal miner feature that was added earlier this year. So this is my Zebra config. I've already started it up, and you can see we're at block height 290 currently. It's going to mine a block onto the chain every 5 seconds or so, give or take maybe half a second. And all I've done here is copy this config into here. And if we scroll down a little bit, it says there are two ways to use it. You can either use the internal miner, or you can use RPC methods directly with our proposal block from template function that's available in the Zebra chain crate. I think the internal miner is easier, so we're just using that here. So we just add this to our config, and let's shut this down so we can start from scratch. All we have to do is cargo run release with the internal miner feature and this config where internal miner is enabled. And it's going to start mining blocks onto Regtest. And we can submit transactions into the mempool with whatever custom consensus rules changes that we've made to the Zebra code base. And it's going to test that you can use those outputs, or you can test that it runs forks correctly. We're doing this in some of Zebra's tests. So that's how we use it with the internal miner. Let's also take a look at how we use this with the RPC methods directly. Here we see some example code. So all we're doing here is using an RPC request client. I believe this is in the Zebra node services crate, getting a block template from the RPC method, converting it to a proposal block, and then submitting that block. And if the submission is successful, we expect the response from the submit block RPC method to contain result null. We're not going to demo this today because it's not as interesting. It would just look like a test passing, but this example code is actually from a test that we did to check that Regtest is working as expected. So that's kind of it for Regtest. We can also take a look at custom testnets. These are public testnets that can be configured with custom network names, magics, slow start intervals. If they have a different network magic, Zebra is going to refuse connections with other nodes that have a different network magic. If it has a different protocol version, it's not going to work. So you have to be using the latest version of Zebra or a Zcashd node in order to access custom testnets. And this can be really useful for larger test environments where there are multiple participants over longer periods of time, maybe a week, maybe a month, where you can test new consensus rule changes or other integrations with the Zcash node. The usage information for custom testnets is also outlined in the book, in the custom testnets page, with configurations that should work as they are here. There's also a section on using mainnet parameters. These are not all the mainnet parameters, but just the configurable parameters of custom testnets that are not reserved for mainnet or testnet being set to their mainnet values. For example, the target difficulty limits, disabling proof of work, which is not at all recommended because it's going to be very difficult to mine blocks onto the chain, the genesis hash, the slow start interval, the network name, the magic, these are still different because they're reserved for mainnet. The mainnet network name and magic are not accessible on any testnet. But the activation heights are available and you can set them to exactly the ones as mainnet. One caveat to point out here is that until Canopy, Zebra cannot produce block templates for these network upgrades. So if you're using these network upgrade activation heights, you either need a different way of generating the block templates, or you'll need to copy over the mainnet states into the new custom testnet state up until Canopy. And that's about it. There's a bunch of other caveats and restrictions that are all noted here with footnotes. Take a look at the book for more details. So I think that takes us to the end of this demo. Thank you for listening.